Okay, picture this. You are starving. Coincidentally, you walk into an all-you-can-eat buffet with a plate and a drink. Also, coincidentally, you only have 10 minutes before your ride leaves. Do you grab the nearest slice of pizza? Do you divide the buffet into sections and conquer them one by one? Or do you take notes from previous buffet runs and build the ultimate optimized plate of food? Well, congrats. You just stumbled into the world of algorithm design methods. Hello everyone, I am Ren Cedric Veran and we will break down computer science concept using food, scenarios, and occasionally actual logic. So personally, if you ask me what's my go-to, I think third option is the best. So today we will talk about three powerful strategies that help computers and sometimes humans to make better decisions. Those three algorithms are greedy algorithms, divide and conquer, and dynamic programming. Each one solves problem differently. Like, you know how your friends all tackle group projects in their own special way. So let's break them down with real-world examples, actual coding problems, and yes, time complexity. Let's go. Yippee! Okay, going to the very first algorithm, which is the greedy algorithm. So what is a greedy algorithm? A greedy algorithm builds up a solution piece by piece, always choosing the option that looks best at that specific moment. That's why it's a greedy algorithm. You're making a greedy choice. You don't think about what's in ahead or reconsider the past choices, whether it's optimal or the best choice that they have done. You just pick what seems best right now. So a real world example for this is, for example, you're in a tech industry and it's very hectic. You want to change pace and that you've decided to settle on your province and start a small business, a sari-sari store business. So your very first customer, a kid, bought a 9 pieces of candy and he handed you a 50 peso bill. So you need to give 41 peso in change using the least number of coins, since it's the most optimal solution in that specific problem. So you pick the biggest coin possible at each step. 20 peso, 20 peso, then 1 peso. Fast and simple. So what is the time complexity of that problem? The time complexity of that problem is big O of n, since there's iterations. So suppose you have coins. Since the biggest coin is 20 peso, followed by 10 peso coin, followed by 5 and 1. So at each step, you select the largest coin less than or equal to the remaining amount. So you iterate, is 20 peso coin less than or equal to the 241 peso? True. Minus it. Is 20 peso less than 21 peso? And again and again and again. So you loop through all the denomination for each amount up to you reach the current n, which is the worst case time complexity of big O of n. So the computational example for this is that an activity selection problem. Given a list of activities with start and end times, choose the maximum number that don't overlap. Sort them by finish time, then pick the earliest one that doesn't conflict. So here's the code. So the greedy algorithm for that is that you sort them by finish time, then pick the earliest one that doesn't conflict. So sort them by finish time, then you look. Does 4 overlap with 1 and 2? Doesn't. 6, you see it overlaps with 3 and 4 since your start is 0, so you sort it out, and so forth, and so on and so forth. The time complexity, the sorting is big O of n log n, the selection is big O of n, and the total is big O of n log n. So the second algorithm is the divide and conquer algorithm. So what does divide and conquer algorithm mean? A divide and conquer algorithm is that it solves a problem by breaking it into smaller subproblems, solving those subproblems recursively, and then combining their solution to solve the original problem. So basically, major problem, divide it, solve those subproblems, solve again the subproblem, then combine it, then combine that solution for that subproblem to solve that bigger problem. Real world example is that, for example, you're a librarian. Instead of sorting thousands of books all at once, you first split it into genres, then authors, then sort that genres and authors. You sort those each section. You divide a task, solve each part, then bring it all together. Easy. The time complexity of that problem is that each split, I believe it's log 2n, each levels. Then each merge is big O of n. Total of n log n. So the computational example, which is the merge sort, which works in the same way as the real-world example. You split the array into halves, recursively sort each half, then merge. So the time complexity is the same. So next we go to the next algorithm, which is the dynamic programming. So what does dynamic programming even mean? Dynamic programming is, it solves problem same as the divide and conquer algorithm by breaking them into sub-problems like divide and conquer. But there's one key difference. It remembers the solutions to the sub-problems, so it doesn't solve the same one twice. So it's called the memoization or the tabulation. So basically same as divide and conquer, but the thing is, it remembers the steps that he did on the sub-problem, so he doesn't need to solve that same problem twice. Real world example is that you're planning a trip. Your dad or your mom aside you to plan the family trip. So you're visiting cities, each route has a cost. You want the cheapest total cost. If you've already figured out the best way to get from city A to city B, you write it down. So you don't have, to recalculate it again. The time complexity of that is that if n cities and k routes, memoization reduces the exponential to big O of n times k. Since the problem, you don't need to solve the same problem again. So the computational example is an LCS, which is I believe, the longest common subsequence. Yes. So here is the code. So given the two strings, find the longest sequence that appears in both. Instead of the algorithm for this is that instead of resolving sub-problems, DP fills a table to store previous result. So the time complexity of that is that with strings of length m and n, fills an m times n table, which is big O of m times n. So going back to the slide. So as a conclusion, a summary of both paradigms: greedy, best local choice. You best what is the most suitable choice for that specific situation that you're currently in. Time complexity is n log n, activity selection. Divide and conquer, divide, solve, and combine. You're repeating the same if you met the same problem, you repeat it. So the time complexity is n log n merge sort. Dynamic programming remembers same as divide and conquer, but it remembers the sub-problems. So the big O is m times n, which is based on the example of the longest common subsequence problem. So yes, each paradigm offers unique strategies for solving complex problems efficiently. So basically that's all. Thank you all for listening, and